So you see how we like to categorize everything in science? Or is breaking things into groups, right? Here we're talking about pure substances. The mixtures are a completely different branch of this. Pure substances we can look at being either elements or compounds. A compound is going to have two or more elements in it. An element is only having one element. But within the elements, there are atomic elements and molecular elements. Most elements are atomic, meaning that the individual particles that we see are atoms, but there are several elements that are found as molecules. I think of these as being a lot like junior high girls. When I was in junior high, somebody at a rally or something that I was at pointed out that junior high girls never go to the bathroom by themselves. They always take a friend, right? And women often do that even as adults. And I don't even know exactly why, but we do it.
So molecular is always two of the same.
Two of the same element.
Is it ever three?
That's a good question. Is it ever three? Sometimes it's 8. Yeah. So there are two that we won't really get into, phosphorus and sulfur, that make even larger ones. But the ones that we're interested in are going to do this. And so you can think of them as having a buddy system, right? These elements, the atoms don't like to be out by themselves. They're always with a friend. So they go everywhere in pairs. When we look at compounds, we can break these down into molecular compounds and ionic compounds. And that has to do with what kind of bonds do they have. Molecular compounds have covalent bonds and they form discrete molecules. Ionic compounds have ionic bonds. That's not confusing at all. Formed between ions. And so we could look at this, and this is called the formula unit for sodium chloride. It represents the formula. But there aren't discrete molecules that are sodium chloride. A chunk of sodium chloride is just a continuous lattice of alternating cations and anions. So ionic compounds don't have molecules. They have formula units, but those formula units are all just jammed together. So atomic elements exist with their individual pieces as atoms. Most elements fall into this category. Then we have molecular elements. There are 7 diatomic elements. So diatomic means 2 atoms. They form molecules with 2 atoms. Here are their formulas, and I'll show you in a minute a way that you can find those on the periodic table. And then phosphorus and sulfur also make polyatomic molecules as elements, but they're not 2, they're 4 and 8. And we don't need to understand why. We don't even need to remember that they do that. They just do. So on the periodic table, highlighted in yellow here, are the diatomic elements. So if you start with element 7 and make a 7, there's most of them. And then here's hydrogen over here, because like I said, hydrogen's the baby brother of the element family, and he breaks all the rules. So of course he's going to be over there. So let's erase this so we can see what we're doing. So that's one way to remember these. Another is with this silly sentence. Horses need oats for clear brown eyes. It works out so nicely until we get to the last one. Oops, not browns. So the first letter or two, H, N, O, F, Cl, Br, and I. Those are the ones that form diatomic elements. If you don't like that, you might like Brinkelhoff. That's someone's attempt to put those letters together and spell a word. Brinkelhoff. We need to know these 7 because when we see them and write them in a chemical equation, their formulas are diatomic. We don't just write F, we write F2. Okay? Polyatomic elements are also highlighted here. We mentioned phosphorus and sulfur. Selenium also does strange things. Just if you see them being polyatomic, don't let it bother you. Anybody have any questions? You need to know the 7. So, molecular compounds. Ionic compounds were a metal and a nonmetal. Molecular compounds are 2 or more nonmetals. And the basic units are molecules. So when we look, if we could zoom in on water, we'd see H2O molecules. Dry ice is composed of CO2 molecules. Here's an illustration of a propane cylinder that you might hook up to a gas grill to, make some hamburgers or something. Propane is C3H8, and that exists as molecules. They are individual molecules. They are separated from other molecules. They're distinct entities. Unlike an ionic compound, where you have the 2 kinds of ions and they're just arranged in a pattern throughout the whole thing. So the ionic compounds, here we have a metal and a nonmetal. We need a cation and an anion. And the basic unit here is the formula unit. It's not called a molecule. Sometimes we get tired of saying molecule or formula unit, and we just say molecule, but we understand that ionic compounds do not have molecules. Molecular compounds have molecules. Here again with the table salt, and zooming in on this, it's just alternating ions. There aren't discrete units. Does anybody have any questions about that? So what about those ions? Ions can be a monatomic, meaning it's just a single atom that's either gained or lost electrons. But you can also have polyatomic ions, which is a group of atoms covalently bonded together. But what makes them different from a molecule is they have extra electrons to be an anion, or occasionally they are missing some electrons to be a cation. So we call these polyatomic ions. Poly meaning many, many atom ions. So if we look at this compound NaNO3, in Chem 1A, all ionic compounds are going to have 2 ions. That's not true once we get out of Chem 1A, but in 1A, we can ignore some of the other more complicated things. There will always be 2 ions. And so when we look at NaNO3, Na is the metal, that's the cation, and everything else together is the anion. It's a polyatomic anion. And we'll talk more about those later. These guys should look a little familiar to you from the memorization quiz. So we need to be able to classify substances. We're going to learn how to name them. And in order to name them, we have to know what system they fall under. It's a little bit like different cultures among humans. We have different patterns for naming our children. My ancestors came from Sweden. And my maiden name was Johnson. And so if I was a guy, that would mean that my father's name was John. So John had boys, and they were given the last name Johnson because they were the son of John, right? And if he had daughters, their last name was Johnsdotter. And so then, Peter Johnson has a kid, and his last name is Peterson. And so every generation, the last names changed. How's that for confusing when you're trying to do your genealogy? There are other countries where the family name is listed first, and then the individual's name. There are some that use a single name, and then you get into our computer system and you have a lot of trouble because they're asking you for your other name, and you're like, I only have one. So this is the same idea. There are different categories, and we need to recognize the category so we can apply the rule. So we're going to practice here identifying these as an atomic element, a molecular compound, or an ionic compound. And so just to review, most elements are atomic. The molecular elements, the only ones you need to remember are the 7 diatomic ones. Horses need oats for clear brown eyes. We recognize elements with their names. Their names always have one word. Most compounds have 2 words in their names, just like most people use a first name and a last name. And when we look at a chemical formula, an element symbol has 1 capital letter. So if you see 2 capital letters in a formula, it's got to be a compound, because that means there's 2 elements. Molecular compounds, 2 nonmetals. We learned on the periodic table that all the elements to the left of that stair-step line are the metals, and the ones to the right are the nonmetals. In an ionic compound, with one exception, you'll always have a metal with a nonmetal. So if we look at fluorine, is it an element or a molecule? A compound. It's an element. Well, is it an atomic element or a molecular element? It's molecular because it's one of the 7. So I'm going to call it me, molecular element. How about N2O? What kind of an element is nitrogen, metal or nonmetal? It's a nonmetal. And oxygen is also a nonmetal. So this is molecular. This is a molecular compound, MC, molecular compound. Silver. It's an element. Is it one of the 7? No. So we're going to call this an atomic element. How about K2O? This is an ionic compound, Ig. The first element is K, potassium, and you might not think of potassium as being a metal because you know that that's one of the electrolytes you need to be getting along with your sodium. And you don't eat metals, right? But they're ions. Question?
Just to clarify, the reason why fluorine is a molecular element because it's diatomic?
Yes. Yeah, it forms molecules. Phosphorus and sulfur and selenium are also molecular elements, but I wouldn't ask you those. I'll only ask you about the 7. How about Fe2O3? I hear little whispers. Say something loud enough I can. Ionic. The first element is a metal. The second is a non-metal. Metal and non-metal make ions. Any questions? Because this is the first step to being successful at nomenclature. And I know, because you went through a prerequisite, you've all experienced nomenclature before, right? And some of you did better than others at it. And we're all going to get better, right? We can do it.